Well, what we're going to talk about today is kind of just Green Building 101 and go through some of the elements of what green building is, start a little bit with the history of it, and then kind of go into some of the components. You will see probably a little bit of crossover today in terms of the other speakers who will be speaking probably in more detail on certain things that I'll be talking about, namely building envelopes, drainage planes, as well as what Mr. Nagin's going to be talking about this afternoon. So I'll touch briefly on a little bit of those things, but still try to stay focused on green building. What is green? A lot of people have questions as to what is green. There's a lot of different various thoughts of what green is. A lot of people, when they think of green, they think of, the straw, clay homes, the straw bale homes that are being put together. That is green for sure. But our traditional homes today, too, can be green as well. This is the trend home that Scott was referencing. In terms of light, guys, can you see this pretty well with the light that's here? Is that okay? Okay. If you can't, let me know. But this, traditional homes today are also green homes. They don't have to look, something very different than what you traditionally see driving down the street in your typical neighborhood. Green building, what is green? Well, there are many definitions of green, but basically we're focusing on reducing the carbon footprint and the use of natural resources and fossil fuels, building in an eco-friendly way, and again, like I said, reducing our reliance on fossil fuels, so trying to minimize the amount of natural gas types of products and electricity in the home. Yes?
Why don't you turn that mic up? We'd be able to see that board better, I think, the screen.
That's what I thought too. If Helen, you got those for me? Thank you. Green building, what is green? There's still, well, we already hit on that, I'm sorry. Green defined, general definition. Green building kind of focuses on these key elements: energy efficiency, water conservation, improved indoor air quality, the use of sustainable building materials as well as resources, and then renewable energy systems, which we'll get into more detail later, recycling of construction waste, and then also smart growth, sustainable land development practices. So kind of all of those items make up kind of the general category of green home building. History of the green building movement. In the pre-20th century, structures were designed and built by architects, builder architects, with an ability to understand the entire building from the design through construction and the lifetime of operations. They did bring in some passive design elements into these buildings and simple mechanical systems to kind of heat, cool, and light the buildings. Now, in the early 1900s, we started to get greater technologies. We started to see more advancement in air distribution systems, the development of the HVAC systems. And back then, we felt that we had these vast quantities of these fossil fuels, so it was really more about just pumping a lot of conditioned air, whether it's cool or heat, into these buildings to make people feel comfortable, to make them feel warm. Not too much concern about how much of those fossil fuels we were using, because at that time it wasn't that great of a concern. With these advances in technologies, the architects started to ignore the issues of their effects on the buildings and occupants. And then we started to get a lot of more specialized trade contractors, traditionally the HVAC specialization, plumbing and electrical, and we started to lose the disconnect of a whole system operation. In 1973, in response to the energy crisis, we had the American Institute of Architects, otherwise known as the AIA, form an energy task force called the Committee on Energy. And then in 1977, the DOE, or Department of Energy, was created to kind of address the energy usage and conservation. In 1977 as well, the Solar Energy Research Institute was founded, the National Renewable Energy Laboratory in Golden, Colorado. 1980, the Sustainable Buildings Industry Council was founded, and a major building trade association is the Passive Solar Industry Council. Then we move into the 80s, and this is where we kind of come around with Earth Day, getting into that time period. The UN Commission on Environmental Development provided the definition of sustainable development, and basically saying it meets the needs of the present without compromising the ability of the future generations to meet their own needs. 1990, we kind of saw one of the first green building programs launched in Austin, Texas. Austin is considered one of the founding cities, if you will, of green building. In 1992, the AIA again got involved and came up with an assessment of building products, kind of looking at the individual products and their life cycle cost and their effect on buildings. 1992, in Rio de Janeiro, they had an Earth Summit, and they developed what they call Agenda 21, which is a blueprint for achieving global sustainability. So now we're taking it out of our smaller areas and really addressing it more on a global basis. Also, at that same summit, they awarded that Austin, the city of Austin, with one of 10 awards for the most innovative government environmental program in the world. And they were the first one in the U.S. 1999, getting here a little local now, in Madison, the Wisconsin Environmental Initiative rolls out their Green Built Home program. That program is still very active today. greenbuilthomes.org is where you can go get some more information on that. But the purpose of promoting green building in the residential sector, primarily focusing on the Madison market, but they've definitely gone much more regional, hitting the northern parts of Illinois, some parts of Iowa, obviously here in the Milwaukee area, for those of you that may be aware of that. And it was the first green building program east of the Mississippi. In 2000, an increasing number of municipalities and corporations began to demand more green building initiatives and started setting standards within their organization for bringing green components into buildings and into design processes. In 2007, the U.S. Green Building Council, USGBC, rolls out LEED for Homes program. Now, LEED's been around for quite some time, but this was their first rollout of their home program. A lot of what LEED has been doing has been more in the commercial sector, government sector, the larger buildings. But now they finally roll out a home program. Just last year, or just the beginning of this year, I should say, NAHB unveils their green building program. Now, the National Association of Home Builders has had a green program that they developed a while back. They revamped it, rolled it back out again in the beginning part of this year, and it's been a pretty great success so far across the United States. Really focusing again on the same things that we kind of talked about early on as what defines green: the water, or the energy efficiency, water conservation, reducing our reliance on fossil fuels, as well as looking at resource conservation. So, why does green matter to us? And what I mean is more of from a global perspective here now. Our country makes up about 4.5% of the global population, which is about 300 million people in the United States, for a global population of about 6.7 billion. But yet we consume 25% of the world's natural resources. So we are a big consumer as a developed country, as a growing company, as one of the and one of the superpowers. We consume a lot of natural resources. We live not only in excess of our means, but also in excess of our resources. Not much a problem in the 20th century, because again, there weren't that many developed countries like ours, but it will be a problem going into the 21st century. And why? The primary reason is globalization, as well as the fall of communism. And you say, why the fall of communism? China and Russia, much depressed countries for years, really weren't consuming a lot of natural resources, really weren't developing as countries, but their fall of their communism has really made them into bigger superpowers in terms of their consumption of natural resources. We've all seen the growth that China has done over the last 5 years. Russia's experiencing that same growth. They're consuming a lot of natural resources. So now we are competing for much fewer resources in the world today. In 1950s, the population of the world was about 2.6 billion people. Like I said, it's 6.7 now. By 2050, the UN predicts a global population of 9.2 billion. That means in about 100 years, we've more than tripled our global population. So China is also projected to consume half of the world's resources by 2015. So conservation is going to continue to be a key element and very important to us as we grow through the next 10 and 20 years. But why does it matter to us as builders, trade partners, architects, remodelers? The concept of green has seeped into the consumer consciousness. If you haven't been asked for it yet by some of your clients, you definitely will in the near future. Energy Star appliances. Energy Star has done a fantastic job marketing their services, their products, the benefits of having Energy Star certified homes, mandatory recycling initiatives, widespread promotion of green programs. We just kind of talked about 2 of them, NAHB's leads, actually 3 of them in Greenbuilt Homes. Energy costs increase. As energy costs increase, consumers will invariably look for ways to reduce their costs. You know, people are always focusing on that monthly payment for the mortgage of their home. It's going to become ever more important for them to start focusing on the operation costs of that home, which primarily a big portion of that is energy consumption. So we're going to see more and more people ask for existing home energy bills to figure out if they can make that home fit their budget. Energy efficient green building, where this one component I'm going to talk about is kind of looking at the building envelope. One of the bigger energy wasters is really in our building envelope, and whether that's being drafty, which is primarily what it is, or not having the appropriate amount of insulation. Airtight construction, Joe Nagin will talk about this afternoon. Build tight, ventilate right. People are always concerned, can you build a home that's too tight? The answer is really no. The tighter the better. You bring in mechanical ventilation to control the amount of ventilation within your home rather than relying on Mother Nature to determine when you're going to get air into your home and when you're not. Very important. We'll briefly talk about some insulation types and techniques, wall system design, and home plan design. Really, in the performance of green building, namely on the energy efficiency side, performance is in the details. Airtight homes begin with the proper building envelope features. So a weather-resistant building paper, Tyvek's probably the most common. There's a lot of other products out in the market too, but basically putting this air barrier around your home. Adjustable door and window or door thresholds, you know, having the ability to raise and lower that threshold so you get a good tight door seal. Windows and doors are your biggest air leakers in your house. Quality windows with the proper weather stripping, very important. Glass in general is not a good insulator, but what you're looking for really is you're looking for your weather stripping around the window so you can get a good tight air seal. And then also there's newer windows out on the market right now that reduce the amount of heat loss conductivity between the inside and the outside. Fiberglass frames are starting to become more popular for that because they reduce that conductivity. Use of quality sealants both inside and out. Airtight homes, again, the basement box sills. If any of you go home tonight, especially if you live in an older home and you go home and you look up just above your foundation and just below your floor deck, you may see a fiberglass band of insulation, and that's supposed to provide some kind of insulating value to you. Fiberglass is a great product to use as long as you enclose it excuse me, on all 6 sides. If you leave it exposed on one side, it basically is a glorified air filter. So you get a lot of air infiltration at that box sill, and it's one of the most overlooked areas in new home construction, and obviously in existing homes it's there already. We also can use blower door tests to kind of test the performance of the homes. Again, I don't want to go into too much detail on building design and construction, but just showing you right here how you can make an airtight home by using the proper sealants. In this case, we use a window tape around the window. Making sure that you get a good quality seal there so you don't have air infiltration around there. Quality sealing techniques, here's an example of the closed cell foam, especially with irregular shapes like you see in these joists. That tends to provide a much tighter seal in that area and gives us that air barrier that we traditionally don't get. Same thing here, we've got 2 pipes going out for our HVAC. You can see again how much tighter we get around those areas, reducing the amount of air infiltration. Not only is it important to hit it on the inside, it's also important to hit it on the outside. These are those same 2 pipes with the air sealant or with the caulking around the outside to minimize that air infiltration again. Insulation types and techniques. First thing is important is defining what R value is, and R value changes quite frequently depending upon how that material is used. When you go and buy a band of insulation at Home Depot or Lowe's, it says it's an R13 or an R19. That's what it's tested out at in perfect conditions. But if you put it in the wrong application, your R value will greatly reduce, especially if you've got air flowing back and forth across that insulation material. But R value is defined basically as the ability of the material to resist the transfer of heat. It's called its resistivity value. The higher the R value, the better resistance to heat transfer. However, the application of insulation is very important, like we talked about. There's two types of R values. There's the effective R value and the theoretical R value. The theoretical R value is kind of what we talked about. It's in a perfect conditions, tested in a lab. That's the ideal condition. That's what gives it its rating of an R13 or an R19. But when you put it in a certain area that it doesn't quite necessarily belong, namely using like an R19 insulation in a 2x6 wall cavity, prime example, a 2x6 wall is 5.5 inches, right? Nominal, or the actual dimension of the lumber is 5.5 inches. The actual thickness of an R19 bat of insulation is 6 inches, so we've got a 1/2 inch difference. When we put that R19 in that wall and we compress it with the drywall in the end, that we have lost R value right out of the gate just by compressing that insulation. And most municipalities now recognize that and won't allow you to take an R19 on your heat calc if you're using a 2x6. They'll make you take it down to an R17 because that compression reduces that R value in that insulation. Also, too, effective R value versus theoretical R value. When you bring wood studs, every 16-inch on center, into your wall system, you effectively have reduced the R value of that entire wall because your R value of a 2x6 is about an R or 5.5. It's about 1 per inch. So you have effectively reduced your R value every 16 inches. There is a product out there, it's a SIPS wall panel system, structural insulated panel system, where they've effectively have removed those wall studs every 16 inches and you get a greater span of solid insulation all the way across the wall. Even though the R value may appear to be similar, your effective R value is much greater because you've taken out these thermal wall breaks, which are the studs. Traditional fiberglass bat insulation, we talked about, very important to make sure that you get all 6 sides covered, okay? When you leave one side open, you greatly reduce that R value. Another product is called blown-in blanket insulation system. This is a really nice product. It's a good seal and fit around outlets and windows. If you've ever seen a bat of insulation installed in a wall system, you've got all the mechanicals you got to work around. Every time you split that bat up, you don't get really good effective R value. Using a blown-in blanket insulation system, kind of like this one right here, really gives you a much nicer pillowy effect of insulation, good consolidation around those electrical boxes, wires, pipes, what have you. Cellulose insulation is considered a very green product. Made with recycled newspaper, basically. It's come a long way. They've done a much better job of making a quality product out of it. In the past, the concern was settling. They've actually treated it with a product now that allows it to stay a little thicker so you don't get that settling. Kind of operates the same as the blown-in bibs system. This is probably one of my favorite products, closed cell foam. Really nice thing about this is it really expands into all those crevices. It's got a lower expansion rate, though, than typically what you'd buy at like a Home Depot. You buy the Great Stuff can and it expands dramatically. This expands at a much less rate, about almost a 3-to-1 or 4-to-1 versus the Great Stuff. But low expansion rate, another great combination of use with this product, because the product is kind of expensive, but another combination of it is what they call flash and bat, where you might just spray on about an inch in your outside surface of your wall cavity and then go over it with a bat of insulation. What it does is it really knocks out that air transfer from the outside to the inside of the home, and then you can use a more cost-effective bat of insulation to give a really good cost-effective high-performance wall. Another good application of this is used in the attic, going over any penetrations like a can light, your wall plates, things like that. Again, I find that the best application of this for the most cost-effective side and a good immediate payback is using it in the box sills in the basement. It's a no-brainer, in my opinion, to use it there. A couple $100, you'll get that back in a few years, if not in the first year. Insulation cost comparison ranked from the most affordable to the, and least effective. And again, remember, you get what you pay for. Traditional fiberglass bat insulation is probably the most cost-effective. It also has a 25% post and pre-consumer recyclables in it. Blown-in blanket insulation would be next. Cellulose insulation Then the flash and bat that we talked about, and probably one of the more premium is a closed cell foam product in the wall system. Now we're going to talk kind of energy efficiency as it relates to lighting and light fixtures. Kind of the next step in green building is looking really at what we're consuming in terms of, you know, the wattage of our bulbs, the electricity that we're bringing in to light these facilities. Energy Star has rated light fixtures. They're called Advanced Lighting Package, or ALP. Uses much less energy than their traditional incandescent lighting, about 2/3 less electricity than your standard fixtures, while providing the same quality of light. The Energy Star fixtures do cost an additional $30 or so on average, but above the traditional fixtures, but the bulbs last a lot longer. They use less kilowatt hours, and you can basically, Energy Star, in their testing that they've done, claim that you could save up to about $100 per year based on an average of having 20 of those light fixtures in your home. So you get greater durability, which is one of the components of green building. You use less energy, and you get the same quality of light. Green fact, if every American home replaced just one light bulb with an Energy Star qualified light bulb, how much energy could be saved? Well, according to the EPA and the Department of Energy, we would save enough energy to light more than 3 million homes a year and save more than 600 million annually in energy costs, preventing greenhouses equivalent to about 800,000 cars. Energy efficient lighting. Here's one of the rooms in the Trend home, and just showing you put a ceiling fan up there. Ceiling fans are very good, especially when you get into vaulted areas or high ceilings. They really help you move the air in the home, get more even circulation and ventilation, as well as heating and cooling. Compact fluorescent bulbs have come a long way. You can get the ones that look like traditional bulbs without having the little swirlies components. I have replaced all of the bulbs in my house with these compact fluorescents. I do it in my models as well, namely in my models because we leave those lights on all the time for display purposes, and I've seen my electric bill go down significantly. So you could buy these bulbs now in much more cost-effective. Energy Star gives great rebates. I just bought some the other day at 99 cents a piece, and they give you a $2 or the $2.99. They give you a $2 rebate right at the cash register. Makes it very easy to swap out the bulbs in your house. Energy efficient lighting. These are sun tubes. These are a great product to use in homes, especially in areas where you don't have windows. So during the daytime, you don't have natural light, like hallways, bathrooms, areas where you don't have these windows. Here's two examples. Here's a hallway, and with the light that you see right now, it's kind of hard to see how much light this really puts out, but it puts out a significant amount of light in the corner of this hallway. This hallway takes a jog to the right. We've got great light coming down it, and we've got great light going to the right. Another example right here, we put a 10-inch one in a hall bath. You don't have to turn the lights on during the day in these areas. You got great natural sunlight coming in. We'll talk next about passive solar design. Probably one of the most cost-effective ways to reduce your energy consumption, take some of the sun's natural solar energy, but you have to think about it in the design before you start. Passive energy design is probably more sustainable than active energy systems. There's really no maintenance. You use fewer natural resources to build and maintain. You want to design your home basically to take natural energy from the sun to heat the home, and design principles to cool the home. Most cost effective than most active systems. No mechanical equipment is there. So passive design solar considerations, probably two of the biggest ones is really the orientation of the home, okay, to make sure that you get the best exposure to the sunlight, the materials that you incorporate into the home, which we'll show in a diagram here, and then I believe our next slide. And then looking at the summer heat, because you got to balance. In the wintertime, you want to grab that sun solar energy, but in the summertime, you don't want that coming into your home. So good design will help to make sure that you can prevent that. In the summertime, the sun is much higher in the sky than it is in the wintertime, so we adjust our roof overhangs to compensate for that. Here's a good diagram of it. In the summertime, like we said, our sun is much higher in the sky. We have our overhang basically right here that is blocking that solar energy from coming into our home. So we're keeping the home cooler with respect to that. In the winter, though, we have our sun at a much lower angle. And so our control factor here being our overhang, with the sun lower, we're able to get more of that solar energy coming into the home. And then what we've done is we've created kind of a thermal mass, whether that's a tile floor or some kind of thermal mass. Concrete is probably your best one. Carpet is probably your worst. But if you could create this thermal mass that you can absorb this solar energy during the daytime, at night the solar energy will start to radiate back out. This heat energy will radiate back out into the home. And then having kind of a good distribution system, your ventilation system, will help move that warm air around the home. WaterSense, what is WaterSense? WaterSense is a new program designed by the Environmental Protection Agency. We'll talk a little bit more about the program, but really what it's designed for is water conservation. And water conservation is a key component in today's green building home. Why do we need water conservation? Everybody thinks, well, water's everywhere. We look at the globe and we see all these water areas, but the fact is only 1% of the Earth's water supply is available for human consumption, only 1%. The rest of it we can't drink, salt water primarily. Demand for water is increasing as our global population increases. We talked about that, but our supply of water is going to stay constant. Sewage treatment facilities continue to have increased cost for treating water, updated facilities. You know, we always find new technologies. Our government puts greater restrictions on water processing, water quality. Obviously, that increases cost. We all hear about down in Arizona and Vegas, those areas that they have extreme water shortages. Their water and sewage treatment bills are tremendous. And you're seeing a lot more water conservation taking place in those areas because basically the economics of the situation are forcing them to do so. Saving water also saves energy. If we can reduce the amount of pumping that we do, like in Waukesha County, we're not getting Great Lakes water, so we've got these large, deep wells that are pulling water up from the aquifer. That takes a lot of energy to bring that water up, then to treat it, and then to deliver it. If we could save the amount of water that we consume on a daily basis, we could save the amount that needs to be pumped out of those wells. Fossil fuels are also required to heat that water. We have water heaters in our home. We do recycle a lot of our natural resources. We recycle paper, cardboard, metal, glass, wood, even oil. But one of the ones that we don't is water, and we need to start taking a closer look at that. In the Trend Home that Scott talked about, we did a gray water recovery system where we're actually recycling water. And we're recycling gray water, which is basically your shower water, your vanity from your bathrooms, your vanity sinks. It won't be your black water from your toilets, but we are doing the gray water. One of the things that we don't recycle in terms of the water in the home is dishwasher water or sink water. A lot of the food particles create a lot of more problems for our filtration system, but using it for the vanities and the showers isn't a problem. Basically what it is we have this UV lamp system in this one particular product that we're using that is our final stage of cleansing the water. A lot of us remember the cryptosporidium scare in the city of Milwaukee many years ago. Basically, the only way that they found to be able to get rid of that microorganism in the water is using UV light treatments. And that's what these products bring in. So we go through, actually before I get into that, I want to back up 1 second. We calculated, though, that based on 1.6 gallons per flush in a toilet, what we're doing is we're using this water and we're using it to go back into our toilets for flushing. So when we do that, we could save about 32 gallons of water a day, about almost 12,000 gallons of water a year by just using this gray water, recycled water, and putting it back into our toilets to use, rather than basically using drinking water in our toilets. So what we've done here, and this is in the basement of the Trend Home, is we're taking our shower water and we're bringing it down into this 75-gallon drum that we have here. Then what we're doing is we're recirculating the water through this filtration process, or first filter, secondary, and our third one, before we get to our UV light transmission filtration system. We take that water, once it's clean, it comes down into a pressurized tank, and when we go and flush the toilet, the water system calls for this water, pumps back up into the toilet, and we use that water again before it goes back down into the sanitation system. So we're using it twice. It's an approved system. The state, it's one of the first residential systems in the state of Wisconsin. It is still considered a commercial system today, but they're really working to try to make it more residential use. The state really would like us to work more on water conservation. Yes, sir.
What's the cost on that?
The cost on this on a retail side is about $5,500. When you're seeing down in the Arizona, in the Las Vegas area, the cost of these systems, the return on them is so much more greater than it is here today. But again, this in the next 5 or 10 years, we're going to see more pressure and more cost on our water distribution systems, and we'll see a greater return on this. But we are seeing more and more of these systems popping up in the Arizona, Vegas area.
What's the
Good question.
maintenance on the filters?
Every 6 months, you replace the filter. Yep, like an RO system. Yep. Every 6 months, you replace the filter. Once a year, you get an inspection just to make sure that it's operating fine, and that's about it. The WaterSense program is an EPA's new program that they just came out with this year. They're piloting it around the country with 8 different builders. We happen to be lucky enough to participate in that pilot program. We're building 2 homes right now under the EPA's spec guidelines to test it and see how it works. But it is a partnership with the US EPA. Its mission is to protect the future of our nation's water supply and promoting and enhancing the market for water-efficient products. Water is becoming a greater national priority. Residential water use accounts for more than half of the publicly supplied water in our countries. Recent government surveys showed that 36 states in our nation are anticipating local, regional, and statewide water shortages by 2013. Tennessee has an extreme problem right now with water quantity in their state. Another concern is California. California uses wells just like we use wells here. And the demand for their water continues obviously to increase. And what they're finding is that the draw on these aquifers are starting to pull the ocean water underground into these freshwater systems. They've got monitoring wells all the way up and down the West Coast now, watching it to make sure that that doesn't happen. And because if that does, that water system is done. So it continues to become a problem for us. Reducing water consumption through efficient plumbing, fixtures, hot water delivery systems, appliances, landscaping, and design and irrigation. That's kind of the basis for where WaterSense is. So not only are we looking inside the home, but we're also looking outside the home at our water usage. It aims to raise awareness about the importance of water efficiency, ensure the performance of water-efficient products, and provide good consumer information. The program actually certifies and labels products and services that perform at least 20% more efficient than our traditional products out there today. And the goal is to save 10,000 gallons of water per year per household. Manufacturers could certify their product through the program. Vanity faucets, vanity faucets account for 15% of our water usage. Toilets account for 30%. Shower heads about 17%. We also are looking at irrigation systems and designers, so we want to be able to reduce the amount of water usage. Again, Energy Star rated appliances, dishwashers, washing machines are all key components of this program. Products not included at this time, though, are kitchen faucets and tub faucets. You still have volume that people need in those particulars, such as filling a pot for boiling water or filling a tub for taking a bath. Those fixtures are not included in this program at this time. What's key, though, is back in the early days of water conserving fixtures, you had those water saver shower heads, which took you an extra 10 minutes to take a bath and a shower because you could never get the soap off. WaterSense is very concerned about the fact that if they reduce the water consumption in the products, they still have to perform at an acceptable level. So not only is it reducing the water, but ensuring that the performance is there as well. They actually survey customers about the products, and the products have to meet those two criteria. So the concern being is that when you install these products in the home, consumers don't like them, they yank them out and put in the other fixtures again. Currently, the certification program is a pilot, and 8 builders across the nation are selected to participate in the program, give feedback on the program, and then they really want to roll it out in the early part, or actually mid-2009 with the new specifications. The pilot specs are looking at vanity faucets. Now, the federal government requires that vanity faucets be less than or equal to 2.2 gallons per minute. WaterSense is looking for those to be at about 1.5 gallons per minute. Shower heads, same thing, about 1.5 to 2 gallons per minute. Our federal max right now is 2.5. Toilets, they want to get the toilets down to 1.28. We remember back in the early 90s when the 1.6 gallon toilets came onto the market. Tremendous improvement has come from those. Now they want to take it another step and knock that down to about 1.28 gallons per flush. Kitchen faucets, though, still must meet the federal guidelines of 2.2. All toilets and shower heads, vanity faucets, all must have this WaterSense certification. So a manufacturer cannot come out and say, well, we meet the guidelines. It actually has to be certified through the EPA's WaterSense program and get a stamp that they're putting on the aerators, which is primarily where the water conservation is coming from. Kohler, Moen, American Standard, there's a whole list of suppliers and manufacturers on the EPA's websites that provide these systems, or the fixtures. Now, we're going to talk about hot water distribution. Another key element is reducing the amount of wasted heated water in a home. Again, back to the fossil fuels required to heat our water distribution system. In the home, all the hot water pipes must have an R4 insulation as part of this spec. Distribution systems, there's pretty much 3 primary distribution systems. The demand-initiated hot water recirculating system, a whole house manifold system, and a core plumbing system, which we'll show you in a little bit here. The ideal system, though, is really to have the smallest volume of water in the pipes at one time. This is the demand-initiated recirc. This is the layout that we chose to do. Basically, what we've created is kind of the circular pattern in the home where we have a main trunk line of pipe being no less than 10 feet, or no greater than, 10 feet from any faucet fixture in the house. So we're minimizing the amount of stagnant water sitting in a pipe. We are recirculating water through this pipe, and each one of the fixtures in the house has a little on-demand button that you push, and this little pump up in these corners begins the circulation process of the water through the home. And it is shown to reduce the amount of heated water required in the home. You're not sitting there with the faucets wide open, waiting for the hot water to come, or running the shower for a couple minutes until the hot water gets to the pipe. That's the idea behind these systems. Here's a manifold system where basically we spoke off within 5 feet of the hot water system, hot water heater, to all of our fixtures in the home. Here is the core plumbing, which is more of a spoke approach. Again, minimizing the diameter of the pipe and the lengths of the run so we can minimize the hot water in the pipes. Landscape design. The landscape design component is probably the most difficult component to reach for 2 reasons. One, our market here loves their grass, and it requires that only 40% of your property that is available for landscaping, only 40% of that be landscaped. The rest of it has to be mulch or planting beds or something that's non-grass related. Turf shall not be installed on any slopes that are greater than 4:1. That's another requirement. The other option is basically to develop a landscape design using a water budget approach. And when you do that, you have to go out and get a certified irrigation designer who has been approved by EPA's WaterSense program to design these irrigation systems. And again, our goal is to minimize the amount of water that these systems use. Just kind of bringing it back on the tail end here of the WaterSense program to kind of equate the energy side to the water side. Letting your faucet run for about 5 minutes is like running a 60-watt light bulb for 14 hours. That's the energy, basically, that is consumed or required to deliver that water to that fixture through the distribution system, through hot water usage, or heating the hot water. By reducing this household water use, we can, in effect, reduce the energy required to supply and treat water supplies at our public facilities. Addressing the climate change. If 1 out of every 100 American homes retrofitted with water-efficient fixtures, we could save about 100 megawatt hours of electricity per year, kind of equating to 80,000 tons of greenhouse gases and 15,000 automobiles off the road. Our next topic is water conservation and stormwater management. Stormwater management is a very important element of green building, and the reason being is that we want to keep our stormwater on site for 2 reasons, especially in our Waukesha County area as a primary example of that. We want to be, in Waukesha County, basically, when we go west of about Sunny Slope Road, okay, the water that we have here, anything that leaves the site, goes onto the streets, typically ends up in the Mississippi River. We're in the Mississippi Drainage Basin. Anything east of Sunny Slope Road goes back to the Great Lakes distribution system. So when our water leaves here and goes down to the Mississippi, it ends up getting into the Gulf of Mexico. We lose the opportunity to reclaim that water in essence. So if we're able to keep it on site and let it percolate back through the soil, back down, and recharge our aquifers, that's very important for us. That helps to maintain a good quality water supply for generations. We've got to keep the water on site or in our market areas so we can keep those aquifers replenished. The other reason why we want to manage stormwater is pollutants. You know, for those of you that are outdoorsmen and fisher, you like to fish, you know, when this water leaves our site, we're taking with it silt, we're taking fertilizers, we're taking a lot of different pollutants. In the roads, there's a lot of pollutants, especially like today. You know, we've got all that salt sitting out there. That all ends up in these streams and these freshwater lakes, and that just kills these lakes over time and the streams over time. So stormwater management is very important to us. We want to keep it localized. We want to recharge the aquifer. We want to reduce the amount that goes out into our streams, and we also want to reduce the amount of flooding that happens during heavy storms. A good example here, wanted to show you, typically in a natural area, we do have a good water balance. Before we bring in any homes or roads, we have an area that accepts a large amount of moisture. The soil is very permeable. We have a lot of vegetation that's soaking it up. It's typically not a problem in a pre-development phase. In a post-development phase, now we've got structures that are, we've got these roofs that are not obviously accepting water. They're not designed to accept water. They're designed to shed water. We've got driveways that are shedding water. We've got roads that are shedding water. We've got less area for this water to get back into our aquifer. So it's important for us to take a look at the considerations when we landscape or when we design or even during the construction of building home that we're able to keep this water on site. Here's a prime example of heavy erosion. A site that is not stabilized properly, doesn't have the proper erosion control, and we get all this silt and all this crud going into our waterways and polluting our waterways. Here's another great example. Without good stormwater management, we're shedding all this water. It's going somewhere. It's going all downstream. I mean, everybody saw the Lake Delton or the up in Baraboo, Wisconsin Dell area. All that water went somewhere. It all went downstream, and this is what happens when we don't control our flooding. It all ends up in somebody else's backyard. Another picture here of flooding as well. So stormwater management is very important. How we do this, A lot of community control is what we're doing. You're seeing more retention ponds in communities, more filtration of stormwater runoff basically through the soil, temporary storage to reduce the flooding like we just showed you, preventing also those harmful pollutants from entering our waterways. Here's an example of a retention pond in one of the communities close by. We have an area basically where we're taking the stormwater management, the stormwater area, and we're going to hold it in this area, and ideally it's going to go down through the soil again and replenish our aquifers. Now if it gets too heavy in terms of rain, we do have these outflows which will go into another detention area or ultimately down to the stream. So those rains that we had last June, these areas could potentially fill up and have to spill over. But for your other traditional rains, we have a better way of being able to keep this water on site, filtrate it through our soil so it gets clean and down to our aquifer. Another example again of a dry retention pond. You'll also see aerators, wet retention ponds. You'll see aeration within them to kind of keep that scum from coming to the top and keep them nice and clean. Another water conservation effort, rainwater catchment systems, a traditional rain barrel system, residential controls, using rainwater catchment systems basically to control runoff and utilize the rainwater like we did at the Trend Home. We utilize the rainwater for an irrigation system. So the rainwater is actually irrigating our vegetation on site, our grass, our plants. We have hoses hooked up to it where we can actually use it to wash the cars. There's a lot of different things you could do with rainwater. This is a pretty big system that we put at the Trend Home. We actually used about a 5,000 gallon system, basically a container, to capture the rainwater coming off the roof. What we did here then is we tied in pipes to that system through this right here. We have a little filter up here that captures any leaves, things like that that might come down. But really the maintenance of this system is relatively minor compared to some other systems, and primarily it's because of the type of roof material that we used on the house. We used a recycled roof shingle, which is a kind of a composite, plastic composite. So we don't have those particulates that you typically have in asphalt shingles. If you use that, you have a little bit more maintenance with it. But we're able to basically water our entire landscaping with the rainwater catchment system that we designed. So here's your traditional rain barrel, as you could see. We do have a product that you can buy that you can actually create and collect this rainwater in your barrels. You can hold it and use it for your watering outside. You can again use it for your irrigation. A lot of great applications that you can use your rainwater for. Also, too, a lot of the things I'm talking about was related to the Trend Home. We actually have a website up, witrendhome.com, where you can kind of go and see all of these different features that we put into the home. Breaks it down by different categories. Again, that's witrendhome.com. Stands for Wisconsin Trend Home. Our next topic, we're going to talk a little bit about indoor air quality, another key component of green building. As we're making these homes so much tighter, you heard me say early on, build tight, ventilate right. What's happening is we sometimes will trap a lot of pollutants in the home. Those pollutants would be basically off-gassing primarily from furniture, carpets, paints, things like that. So indoor air quality as well as condensation would be a key component of indoor air quality. It's very important in new home construction today. Humidity control is probably the #1 cause of premature deterioration in homes. Basically coming from your showers, any washing products that you're using. Off-gassing of new products, carpets, paints, stains, glued products. Carbon monoxide is another big one. Your gas-fired appliances. A lot of people like using gas ranges because they have a good even cooking component of them. That gives off a byproduct, and that byproduct needs to get out of your house so it doesn't linger in your house. Using good ventilation, like if you're using a range hood above or a built-in microwave, ventilating that directly to the outside, not using those charcoal filters or those recirculation vents. You really want to be ventilating with quality fans, all of that directly to the outside. Occupant influenced. Smoking, people who smoke in homes. Fireplaces, especially wood-burning natural fireplaces, are a cause for a lot of indoor pollutants. So why is there so much more emphasis on indoor air quality today? Today's new home is much more tighter than it was in years ago. It also has indoor pollution sources releasing gases and particles into the air. Inadequate ventilation can increase our pollutant levels in the home. So not enough fresh air being diluted into our air into the home will cause problems. Sources of pollutants as well, cleaning supplies, air fresheners. A lot of people like those oil, oil air fresheners, Glade plug-ins, you plug into the wall. I mean, basically, that's giving off an oil byproduct into your home. And if you're not diluting that with fresh air, that oil starts to stick on surfaces, carpet, paint, and also, obviously, too, oil is not probably a great product to be circulating in terms of the vapors through your home. Wet, damp carpet, mold, mildew in breakfast areas, bath, kitchen areas also could come from condensation on the windows. Soil gases like radon. We live in an area where we do have radon in our soil gases. That does come up through our foundation. Older homes have many more sources like oil, kerosene, asbestos, old appliances, especially older furnaces, sometimes with cracked heat exchangers. You get some nasty air particulates as a result of that. Carbon monoxide from attached garages. So what can you do? Install quality exhaust fans in your kitchens and your bath. Direct those to the outside. Again, especially in kitchens, don't recirculate them back at you. Thinking a charcoal filter will take care of it. 100 CFM is minimum in a bath today. 50 CFM is minimum in a kitchen. One of the things that we do in every one of our houses is, and Joe will talk about this afternoon, we Energy Star test every one of our homes. And the basic Energy Star test is to do a blower door test on the home, kind of do an infrared scan on some of the walls, make sure the insulation's all where it's supposed to be. One of the additional steps, though, that you could take is you can have all your fans tested, and Joe's group can do this for us. We have all the fans tested in our home. What's very interesting is a 100 CFM fan does not give off 100 CFM of ventilation. It does as long as there's no exhaust port attached to it. So we have to get an exhaust port. We have to get that outside. So anytime we connect a tube to the back end of that fan, we reduce the amount of ventilation capacity that the fan's been able to do. So traditionally, a 100 CFM fan may perform around 60 or 70 CFM in the home. So that's why we really say you've got to step up that fan, because it's not going to perform at that 100 CFM. It's going to perform under that, and ideally it's going to perform somewhere in that range of 60 to 70. So that's why we say 100 CFM there. ERVs and HRVs, energy recovery ventilators, heat recovery ventilators, those are all ways that we can use to bring in fresh air, controlled fresh air from the outside. A lot of these products now can actually strip some of the heat that's leaving the home and bring it back in. The energy recovery ventilator transfers what we call sensible and latent heat, so it actually transfers humidity, where the HRV just transfers just that heat component without taking into the humidity into consideration. So again, when we take our diluted air, when we take our exhausted air out of the home, these products are kind of stripping that heat energy that's going out. So you're not taking all of your heat energy and shoving it back outside to bring in cool, fresh air. You're actually stripping some of that heat energy from that exhausted air and bringing it back in with the fresh air. Change your furnace filters more frequently. That's another key element to improved indoor air quality. Installing what they call a MERV filter system. You can go now and you can buy these 4-inch box filters, and you can actually get a slot to go right into your furnace system that you can put these 4-inch box filters in. You get much better performance out of those MERV filters, and you have to replace them much less frequently than you did with your traditional 1-inch filters. Electric and ultraviolet light cleaners are also great products. Here's kind of one of those HRVs where basically what we're doing here is our air is being exhausted And what we're doing is when we come through this chamber system, we're actually taking the heat from the air that's going out, we're taking it and grabbing it and bringing it back into the house. That's kind of how that HRV works. We're replacing the stale and polluted air with fresh outdoor air, and the outdoor stale air is tempered by that fresh incoming air without that cross contamination. HEPA filtration system. Broan makes a great product. Not only are you getting that air mixture in the home, you're also getting a better filtration product. We find that these products work really well with people that have allergies, children that might be more susceptible to dust allergies. This is a great product. Takes out material as small as 3 micron or 0.3 microns. So yeah.
Is Broan the best on the air exchangers?
Boy, there's a lot out there. It really depends on the application that you're looking to use it for. I use Broan for 2 reasons. One, it's a local manufacturer. I like to use local manufacturers. 2, I've found that the performance and the satisfaction that I get from my homeowners, they really like it. And especially those that have had a lot of allergies where, we don't put any carpets in the home or any vinyl flooring in the home. They really do like this particular product. So I've had great success with it. But there's a lot more other products out there too. Yeah, there's a lot of different things you can do with that. So what can you do? Don't use any solvent-based cleaners in the home. That's probably the big one. When you get into the solvent-based cleaners, you get a lot more of off-gassing byproducts that really tend to be more irritants. Try to use more latex, revert from using like non-latex caulks in your homes, especially when you get into 1-part polyurethane caulks. You tend to get more off-gassing. Silicone sealants, if you do use them, obviously, they're good performing sealants for your bathtubs. You just want to make sure that you ventilate that area properly. Again, that'll be an irritant. Look for low formaldehyde glues in furniture and cabinets. Use dehumidifiers in the summer in your basements. Even new homes. I mean, in my home's only 4 years old, and I use a dehumidifier every summer. It's a great way to control moisture sources because your basement's still going to be giving off some level of moisture. And use low volatile organic compounds or VOC paints and wall coverings. So resource efficiency is our next one, sustainability. Kind of looking at basically products that are more sustainable, products that are not necessarily depleting our natural resources as much. But basically the definition of sustainability is a method of harvesting and using a resource so that the resource is not depleted or permanently damaged. That's Webster's good definition. Materials also that can be readily renewed or reused in another application, minimizing the need to generate new products from natural resources. Construction materials may comprise as much as 40% of raw materials extracted from the earth. Yes, sir?
Sorry, what's your thought on humidifiers?
You have to be very careful with them because in the wintertime, when the temperature drops below a certain level, if that humidifier is not tweaked down a bit, you're going to be pumping a tremendous amount of moisture into your wall system. And what happens is in that freezing zone, you get more condensation. The best ones that I've found have been ones that are able to tie without any control from the occupant to the outside air temperature, so it decreases as the temperature drops down. Balance and control is very important when you use humidifiers. They have their place, there's no doubt about it. But control is very important, and when the temperature outside changes, you got to make sure that you're monitoring the humidifier for that reason. Good question. Additionally, construction and remodeling generates about 136 million tons of waste annually, and all of that goes into our landfills. Sustainable materials examples, denim, blown-in fiberglass insulation, any products that you can obtain locally, like rock, stone. We've got a lot of great quarries here. Products that we ship from other parts of the country or other parts of the world, even though they might be green in that, in that country, considered green in that country. Once you put them on a boat or a truck, they're not considered as green because you're shipping, and all that shipping obviously creates particulates in the air and pollution. So we want to really look at more taking products here locally rather than buying products from other parts of the country. Wheat, seagrass, cork, bamboo. Bamboo is green as long as it's harvested locally. When you put it, again, when we pull it from the rainforest or we pull it out of China and again we put it on a boat, it's not really considered green, again, because of the particulates and the pollution basically that's required to get the product over here to be installed. Sustainable harvested wood, we actually have tree farms now that are growing specifically for construction material rather than taking from old growth forests. So resource efficiency materials, material types that could use and can save natural resources. A few examples, I-joist or dimensional lumber uses up to 35% less fiber material. Hollow brick versus solid brick, you're using less, you still have the same strength, but you have less materials. Using the certified wood products, which we talked about. The best practices in the forest management is the certified wood products. You actually get a certification on the wood. They actually follow that particular wood product from the time that it's taken down all the way to the supplier who then ships it to you. There's a complete certification process for that. Environmentally restored health and ecosystems, again, with the certified wood products, they are replacing those ecosystems rather than just stripping the area. Using post and consumer products, now we're into recycled materials that have been previously used by consumers. Recycled building content materials, cellulose, insulation, up to 85% of that product is a paper product recycled. Fiberglass insulation, 25% post and pre-consumer recyclables. Carpeting with the recycled content, including the carpet pad. Fly ash or slag, we're seeing a lot of that product. It's basically a byproduct of coal-fired plants. We're seeing more of that going into concrete. Today, we use a lot of it we use about up to 20% in our foundation wall system. You can actually replace about 40% of the cement while maintaining the same strength and durability. Oriented strand board, another recycled product basically made from wood chips. On general, we talked about this already, but 136 million tons of construction-related waste goes into landfills on an annual basis, which basically accounts for about a third of all the waste that goes into landfills. Up to 70% of this by weight can be recycled. We can recycle the wood, the cardboard, metals, plastic, drywall, a lot of different products from our new home construction. So basically, construction waste management historically has been these giant dumpsters sitting in the front yard which collect all the debris and typically also tend to be always in the wrong place when you need to get access to a certain part of the lot. So we're going from this to more of the smaller containers. We're using less space on site to store our waste, and then the waste basically doesn't stay on site very long. Once a week, we have our guy who comes out and actually empties every one of these bins. And then he takes it to this place out on 107th and Brown Deer Road, Citywide Recycling, which is basically a landfill diversion company. And what we do, this is our guy that we use right here. What we do is basically he comes into this facility and it's a single stream recycling. So you really don't have to, from a trade point of view, you don't have to separate the aluminum, the cardboard, the wood, and all the different products. All of it goes into that single container that you saw. So what he does, he takes it and he brings it to this facility, they dump it on the floor, and historically, this is how they've all done it, sorted by hand, but they brought some more mechanical means into it. Here's a gentleman here sorting the different metals by hand, aluminum cans, non-ferrous versus ferrous metals. And they just invested in this new larger sorting machine. So now they're able to do much more effective sorting of these products. And what they're doing with these products then is they're taking them and selling them on the secondary markets for these post-consumer product to be reused and put back into other materials. Here's our brick and block. Here you can see we have our cardboard coming out. So all these products this company recycles, and again, we're taking upwards of 70% of our construction waste and we're reselling it back out on the market. Now, some people say, you know, what does this cost? This has to cost more. Actually, I've found that my costs are less using this system than using your traditional dumpsters because I'm not paying as much tipping fees, as only 30% of my waste goes to the dump site or the landfill. I'm paying significantly less tipping fees, and I've found on average to save anywhere from $75 to $125 a house by using this system versus your traditional dumpster. So economically it makes sense as well as from an environmental point of view. Renewable energy is one of our last topics. Passive solar we already discussed. Geothermal we'll talk a little bit about. Geothermal provides heating and cooling without natural gas and minimal use of electricity. Solar photovoltaic, which is our solar electric and our water heating, and wind energy. So when we look at geothermal systems, basically we're utilizing the Earth's energy to heat and cool the home. The Earth has a constant temperature of about 55 degrees, around 7 to 8 feet below our surface. It stays pretty consistent. We use the Earth as a heat sink for cooling, much like a refrigerator. With a refrigerator, you put a warm can of soda in, and you come back an hour later and it's cold, and how did that all transfer take place? Well, what that refrigerator is basically pulling the heat out of that soda and dispensing it in the back of the refrigerator where that coil is. Well, we're doing kind of the same thing with geothermal. In the summertime, we're pulling the heat out of the home and we're taking it out and we're sinking it into the earth. In the summertime or in the wintertime, we reverse that process where we go grab heat energy from the earth and we bring it into the home, taking that cool air back out when we recycle through the geothermal system. So we're extracting that heat energy from the earth. What's great about geothermal is it's a 400% efficient system. There's nothing else like it in terms of mechanical equipment that is that efficient. So for every 1 unit of energy it takes to run the system, we pull 4 units of energy out of it. So your best, highest performing furnace in today's market, York just came out with it, is a 98% efficient furnace. Best furnace out in the market. This is four times more efficient than any other piece of mechanical equipment. Slightly larger piece of equipment in the basement, but you don't have an air conditioning condenser on the outside. That's one of the other nice things about the product is you don't have this noisy air conditioning condenser unit on the outside. It's all contained inside the home. So the principle of geothermal in our cooling mode, basically we have our return air, so we're pulling the warm air out of the home and we're running it down through these tubes, which I'll show you a little diagram later, but we run about 150 feet of this piping underground for every ton of heating or cooling that we do in the home. So if we have traditionally a 3-ton heating system or cooling system, we're running 3 times. We're going out 150 feet and back, so it's actually a 300-foot loop, and then we go back out again and one more time. So that's basically how the system is set up. So what we're doing is we're going out and we're taking that heat energy and we're dispersing it into the earth and we're pulling back in that cooler energy, that 55-degree temperature basically, and through this energy fluid and into our system to basically be distributed through the home. In the heating season, we reverse that. We're taking that cool air out, we're bringing it out into the earth, we're absorbing the heat energy from the earth and bringing that back into the system and converting that energy into the heat for the home. The geothermal system, this kind of just shows a general loop system, but all these loops come back and are tied into a manifold outside, which then brings that energy back into the home. One of the probably the most common systems and probably the most cost-effective system is the loop system. So, but you need a lot of land to run this pipe. They're about 150 feet long, again 150 feet out, 150 feet back for each ton of cooling. Requires a larger land area, and these either can be filled with glycol fluid or water fluid or any type of heat transfer fluid is basically what we're putting in these pipes. And this picture here shows a 3-ton home You can see we've got 3 loops that we've had here. Another system for areas where we have smaller land space to use is the vertical well system. The vertical well system, we're basically going straight down versus horizontal. A little bit more cost effective, but great to use in areas where we don't have much land. There's 2 types of systems here. One is called the slinky system, where basically we can get a lot more coil in the ground in a smaller area. And then here's our traditional loop system, where we go out 150 feet and 150 feet back. Solar power, probably one of the cleanest, safest, renewable energy systems in the marketplace. We're now using the sun's energy to generate power and heat. The amount of sunlight hitting the earth in just 1 minute is enough to power the world's energy needs for 1 entire year. So there's a tremendous amount of energy that comes from the sun. What is a solar electric system? What is it? Well, basically we're converting some of the energy in the sunlight directly into the electrical energy for the home. Primarily use the visible spectrum of light energy, not the heat. Photovoltaic, what does it stand for? Well, photo means light, voltaic means voltage or electricity, so that's kind of where that definition comes from. You'll also might hear it referred to as PV. So basically how it works is when the sun's light comes and hits our panels, we split the electrons and the protons into 2 separate areas, and we take back in kind of a DC current, just like a battery, just like your flashlight. You have one current coming in and you have one current coming out. It's the same thing that we've got going in here to our load down in our basement. So it's a direct current that we then convert to an alternating current in our basement. So here's our traditional system. We have our panels. We have an inverter that converts it back to alternating current, and probably the most cost-effective way to manage it right now is to send it back out onto the grid rather than trying to store it in the home and distribute it in the home. So like in the Trend home, what we're doing is we're actually, every watt of energy that we produce with our solar system, we transmit directly back out on the We Energies grid, and We Energies pays us for that. And then we buy the energy back in a different form from We Energies into the home, but the most cost-effective way really is to send it back out onto the grid. Here's installation of the panel system on the Trend home. Panels have become a lot lower profile than they had in the past, so they become more architecturally acceptable, if you will. Solar hot water, same principles as solar electric, except we're taking a heat transfer fluid that runs up into those panels and then comes back to a water tank. We traditionally have 2 tanks. We have the tempered tank, and we have our traditional backup gas-fired or electric powered hot water system. So we're tempering the water that comes in off of the panels into this tempered tank. So we bring it up to about 80 to 100 degrees versus that traditional water that's coming into the house at about 35 degrees that we have to heat up to get to that 120 degree temperature that we need for our dishwasher and washing our clothes. So you'll see traditionally 2 tanks in your basement for the solar hot water. So we have our collectors on the roof. We have our heat transfer fluid that goes up, takes the energy that's collecting from the sun, brings back down and circulates through the water in the tempered tank, bringing that water up to a temperature that's much greater, again, than it would be coming in from the street. And then we dump that over into our traditional water heating system. Here's one that we did at the Trend home where we actually got a product. It was a brand new product which basically took the tempered tank and your gas-fired backup tank and brought it all into one tank. And we found that, obviously you save a tremendous amount of space, and it becomes more economical in the future. Wind power. Wind power is one of the oldest forms of renewable energy, developed in Denmark in the late 1800s. One of the cleanest forms of renewable energy as well. Still not quite effective for traditional residential, but we see more and more of this coming. So we started with the old Dutch windmills in the 1800s, and we moved, over 200 years, we moved to the wind farms that you kind of see up in Dodge County now. So we're seeing a lot more of these pop up. Resource efficiency, finished materials. We're seeing a lot more recycled components being put into finished materials. Mohawk makes a carpet where basically they're taking 37% renewable ingredients of the carpet is actually made from corn sugar. Recycled glass countertops, very beautiful products that can be made with recycled glass. We're seeing a lot more of this come into play. Great color usage. Durable materials. Another key component of green building is durable materials. The less that it takes, the less time that we have to replace these materials, namely windows and other products, the less material goes into landfill, the less cost for the owner of the home. Using durable materials is a very important element of green building. So really looking again at that life cycle cost. Not only what does it cost for you to build a home, but what does it cost for you to own it, to maintain it over the course of the time that you spend there. So with this and reducing maintenance costs, we actually can show that you could save money and increase the value of the home. A lot of people know durable materials, brick, natural stone, fiber cement siding, ceramic tile, metal roofing, concrete. All these products are recyclable as well. But if you double the lifespan of a product in the home, you basically have the environmental impact of the construction. So if we double the life cycle of that product, we obviously reduce the amount of time that we have to replace it and the fact that all of that product may end up in a landfill at some day. When maintenance becomes part of the material's life cycle, it becomes an environmental and an economic burden. So you're buying materials to maintain it, whether it's paint to paint the siding, caulking, whatever it might be. Obviously, there's some cost in that. Our last topic we want to hit on just real quickly is green building certification. Talk a little bit about the programs that are out there. There's a lot of buzz about green building and green products. It's very important to have a resource that can be the verifier to certify that the claim of green. You're going to see a lot more green washing, as they call it, coming with products, processes, as green becomes more of a marketing opportunity for companies. Really making sure that you have a certified product like the WaterSense product and like some of these green building products. Many certification bodies, some within the industry of which the product is made. Some are independent, like ANSI certification. Private sector, nonprofits, LEED is a great example of that. In the home building industry, we have the following. We have Energy Star, which is a complete independent organization. We have Greenbuilt Homes, which is a Wisconsin nonprofit sponsored through the Wisconsin Environmental Initiative. We have the National Association of Home Builders program, the Green Building Program. It's in right now for ANSI certification, so that's another integrity component of their particular program. And then LEED H is what they call it, and that's the LEED program for residential construction. Green Building certification, these are really the four big ones that are available now, especially on the building side, that have the third-party verification for the state of Wisconsin. There are other great programs as well. American Lung Association has a program. EPA has indoor air quality programs, but like I said, those are the four big ones for us right now. Certification and verification are very important to assure that you're getting a green and energy efficient home. So use those resources available to you if you really want to back up your statements and make sure that nobody can challenge the integrity of your product or your process. That's all I have, guys. I want to thank you all for coming today and taking the opportunity to learn more about green building. We have, the association here has a green building council that meets on a quarterly basis. If you guys have any interest in it, contact the association. They'll get you on the mailing list. A great education tool is one of the reasons why we developed that committee for this association.